Earth, the blue planet, the third from the sun. 4.5 billion years of evolution. Interconnected biosphere with a multitude of ecosystems working together to maintain this flourishing life. Mars, the red planet, the fourth from the sun. Mars has ice poles, an atmosphere, and weather, but no life on its surface. Yet we are going to discover, to explore, and this time, to settle. Despite their differences, the two planets share common ground. What we need to bring on Mars for life is what we need to protect on Earth, right now. What if we could use the same technologies on both planets to build places where life would be preserved? Welcome to a new world.
Thank you. So we saw this video. Can you tell us more about your project and how exactly does it work?
Sure. We are a US-based company with offices here in Paris, and basically what we're working on is to design, design and build space station on Earth. So we're planning on opening 10 stations in the 7 coming years. And what we're looking at is basically designing the food, water, and waste management system to put that in a closed ecological environment and to design a station around it for astronauts, scientists, and the general public.
And how would it be like to live in one of those stations?
So it's not designed for permanent living. It's designed. Maybe I can put what I'm speaking some images. It's not designed for permanent living. It's designed for people to experience, to come there and to stay for a week. And I'm just going to put a slide so you can visualize. So it's designed for people to stay there a week or so, and basically the purpose is for scientists and engineers, our team and other people, to test and try new technology that will be needed in the future in space but are needed right now on Earth, so regarding food production, water treatment and waste management. And it's also designed for astronaut training. So the total station will be able to support around 100 people. And so it's a very unique station because no one else is doing it actually. The small NASA analog that you have can support between 5 to 10 people maximum. And so we're offering a unique opportunity for astronauts at a very big number of astronauts actually to try how to live in a closed environment. And it's also open for family, kids, everybody. Basically to experience a new way of living. So the experience will be, so you'll come here, you leave everything, your phone, your clothes, all your stuff. We give you an outfit. Then you join a team. It can be the space team, the farmers of the future team, the builders team. And then you join the village. And during a week, you completely cut out of Earth and you experience what it means to live on the station. So you take part of the daily activities as like farming. You study the different planets, understand the climate of our planet. So yeah.
What a project. How did you get the inspiration for building something like that?
Okay. So before that, as you said, I was an investor. I was a venture capitalist, but this is not my passion. Okay, when I left, I was asking myself, so my previous company, my previous fund, I was focusing on helping entrepreneurs all around the world building hardware devices. So helping people that are really building stuff. So robotics, drones, clean technology, green technology. And the specificity of the fund that I created was to bring support in manufacturing to those companies. And so I spent a lot of time in Shenzhen. I had an office in Tokyo, but also spending a lot of time in Shenzhen. And I was helping those entrepreneurs build their devices. After 5 years of doing that, I was very We were helping a lot of entrepreneurs, but all the solutions that they were building were made in China, most of them, in a very unsustainable way. And so when I left, I was really looking into building something this time myself that will not harm the environment, and on the complete opposite, that will provide solutions that we need right now on Earth. And so I started looking at so all the solutions that we needed for food production, water treatment, and waste management. And at the same time that I was doing that, it was the time where when SpaceX, actually the boosters came back. And I was like, oh my God, I can actually, if you think about living on Mars, you need to design regenerative life support systems. And the solution that we need on Earth are regenerative environmental solutions. And so there was an overlap between the two. So this is how I came up with the idea. And basically, I dream of that since I'm a kid. So when I was I mean, like most of people, I guess, here, but I was playing the little scientist. I was doing drawings to become an architect. So I just also follow my inner child, and I'm doing what I love.
So the bioregenerative system meant to recycle food, water, and energy. Yeah. It's really at the heart of your project.
Yes.
And can we say it represents a way to tackle the issue of global warming on Earth?
Yes.
And maybe other issues as well to protect our planet?
Yes, completely. I can show maybe a drawing that will help you understand. So one thing to understand about what we're building is that so in space there are two different approaches. So we're taking space approach to design system on Earth. So we're really looking at what it means to live on another planet, and we're taking Mars. What are the constraints, and how can we build the systems that are needed there? And we use this approach to design a station here. And so what we're focusing on, and the difference, sorry, what I wanted to say, the difference compared to other space approach is that we don't have what is called a physical-chemical approach. We have a biological approach. So we use plants, and we combine plants with software and hardware to find an equilibrium and to provide the food, recycle the water and the waste. And that's a very different approach than the one that you can have in the International Space Station. And so that's actually one of the reasons why the system that we're building, even if it's using the space approach, have tons of application on Earth. So I'm just trying to, sorry, the clicker is not working very well. So I just want to show you maybe a plan of, that's the team, voila. So each station that we're planning on designing, they're gonna have some slight difference when it comes to the technology we're gonna put in, but they all design as a closed ecological system. And there are, with this closed ecological system that we're designing, there's basically 6 SDG that we can provide solution to. It comes from like clean water, life preservation, action against climate action, building new type of infrastructure that are bioregenerative and recyclable. Also infrastructure in the design and the building and conception of the entire village. So there are tons of application on Earth. That's a cut of the test module that we're going to build this summer. So what you can see is basically the greenhouse and the aeroponic system that is attached to our water treatment system with our waste management system. And so one thing that we're exploring is in the future is how we can spin off one of our solutions, and especially for water treatment, because our approach for the water treatment was to combine different set of technology, but also to design a constructed wetland where we use plants to do the first decontamination of the polluant in the water. And so we technically, because we haven't built it yet and we're building this summer, we are able to turn black water into potable water using very low energy solution and using plants. So that's what basically the space approach is helping us finding solution and closing the loop and finding solution that we will be able to spin off on Earth, maybe to bring some solutions.
Okay, so it's really challenging. You choose to develop space-inspired stations where you could actually work on Earth-like station. Is it a challenge you wanted to?
So it's the why we choose this approach. So why we use space? Why we're using space back on Earth? Because when you have to design habitat to live on another planet, so let's say on Mars, what you need to build is also to build a model where you balance all the masses. So you need to find an equation where everything is completely closed, and there is very little room for error, because when you're designing for space, it's obviously if it doesn't work, then people die. So having this constraint as a design approach at the beginning is pushing us to find more efficient solution, more sustainable solution that can last a longer time, and that also we can put in smaller boxes, basically. So even though we are not applying right now in the design of the first station, we are not taking all those constraints, not all of them into account, but there are some of the space constraints that we're taking that are forcing us to develop solutions and systems that are much more innovative than if you were only focusing on Earth. And so that's an angle, that's an approach, and it's also a business model to use space back on Earth. Space is very exciting. I don't believe we can go and live on Mars if we cannot figure out a way to live sustainably on this planet before. And if you look at the timing, we basically have 7 to 10 years to design systems so we can go to Mars and build the first habitat. And we also have the same time to find solutions that we need to implement on Earth. So there is an alignment, basically, of the timing between the two planets, which I found very interesting. So that's why we're using that here.
Okay. Yeah, you were talking about the constraint of a space environment. For instance, we know that on Mars, the stations will have to be pressurized to protect us from the Martian atmosphere, which is 96% of carbon dioxide, sorry. The wall has to be thick to protect them from space radiation. So what material have you planned to use for the space stations?
So we don't know yet exactly, because right now we're really focusing on the food, water, and waste. That's very pretty much what we're doing right now. But on the materiality, there are different things. So if you think about Mars, it's not only about the radiation. So radiation are much more important when you travel from Earth to Mars. But when you arrive on Mars, there are other things you need to take into account. The temperature. So you need thermic. You really need to protect the habitat from the variation of temperature. Regarding the radiation, Earth has a magnetic field which is protecting us. Mars doesn't have one. I mean, a very, very small one. So one thing that we will explore is how we can recreate a magnetic field around the habitats that will eventually protect us from the radiation. So you have the temperature. So it means you need to build not only thick walls, but also fine materials that will protect from the variation of temperature. It's very, very cold on Mars. And UV as well. So you have ultraviolet that are coming. So there are different materials that you can build. Some companies, and we like them, we know them, they're focusing on building materials using in situ resources. So it's the Martian soil and mixing it with other material to develop new type, for instance, of concrete. There is another type of material, which is the sulfur concrete, which can be made on Mars and cannot be made on the moon, for instance, but you can use on Mars because of the pressure. That can protect. And there is also water. So water has a lot of very interesting, how do you say? Yeah, it can be very useful not only to eat and to drink and support life, but also to protect us. So if you put around 40 centimeters of water, basically it can help protecting and give a shield. So it's a very interesting way, eventually putting water in big bags will allow us to let the sunlight coming into the greenhouse and at the same time protecting life that is under the domes. So there are a lot of things to explore still, but yeah.
Okay. And so when we will be able to see the first station built on Earth, where will it be?
Yeah, okay.
Because we're really excited about the project, right?
Thank you. So the plan is to start so right now what we've been doing with the team is to design the plan for a smaller version of the station. So it's before building a station for 100 people, we want to test for 5 people if our system and the way we're combining things is working before putting people there. So we're starting the construction this summer of a small test module. So designed for 5 people and basically using the same approach and technology. So that's one render and this one. always helps visualize, but that's what we want to. That's what we're going to start building this summer, and hopefully we can start having people coming there in September. So all the team wants to go there. We have explorers that reach out to us because they want to spend time here. Explorers that went to different analogs and knows the system to help us improve and perfect the system. We have also astronauts that are going to come there. So starting September to January, we'll run the tests, and I hope then January 2021, maybe for Christmas, okay, maybe Christmas 2020, we'll be able to open for the general public to come and see visit this small version of the station.
You talk about astronaut, will Thomas Pesquet will be there?
I haven't talked to Thomas yet, but yeah, hopefully soon.
Okay, thanks a lot for your...
Thank you.
And this is a very exciting project. Barbara Belvisi from Interstellar Lab.